I color-coded it so you know the difference between the buttons and the energy. This one's more of an animation. You take your hand across the rings, and then concentrically the lights go on and off. I did some experiments in relocation. This one's set up so that you just go along the strings, and then as I go along this string, then the lights go like this. A lot of this is aesthetic, but if you just want to get down to the nitty-gritty, all you need is a comb. You have 30 buttons in like a 5-inch space. Here's a 180-degree relocation where you just touch down and it makes the up go on. These are only useful if you're just on the board. If you're just connecting it to wires and things far away, then you don't need any of the mumbo-jumbo relocation. This is the pattern inside of a drum machine. I like it a lot. If you open up a calculator, you'll see examples like this. Any button, any Hewlett-Packard printer. The stuff I take apart and make sculpture of, like the aesthetic, pleasing textural stuff, it goes to the art that's just kind of for show, for looking. And then the inside circuit boards are either used directly or inspire kind of electronic art. This one's relocation, where you go left and then the light goes right. This one's a complex one I never really finished. I made the boards, but it's set up so that you have to touch any two places, and then the lights in between those go off, because one hand is making the energy positive go through, the other hand is making the energy negative go through. Kind of redundant. I mean, you only need one finger just sending one energy through. You don't need to open both gaps. Here's a certified calculator. Here's what I copied of it. Here's a thumb board I made. You can kind of see the hand already in it. The fingers splay along the front, and then on the bottom, you've got thumb placement. This guy is a smaller version of these big boards I make. You can count those lights. There's too many. There's the back. Each one of those is a reflector made out of some plastic. Reflective plastic. I get it from Michael's and cut it into like a Red Baron quatrefoil, and then just fold it up. Turns into kind of a square crescent. Here's where this is going. This is a little more complicated. This is a light typewriter. All of those are buttons that look like the letters. I like working directly at the board. That's the pinout for the alphabet. And you say alphabet. How can I get the alphabet up there? 13 lights. If you ever see the displays on the front of calculators and VCRs, you look like close at it, and you can see how they sum up what the alphabet is. I'll show you what it looks like. Here's the routing on the back of the circuit board. You notice those black pins, they go through to the front. It's kind of it's two-dimensional work on circuit boards, but it's two dimensions. You have the front and the back of the board. And you just put a jumper through the board, and all of a sudden you got a different canvas to work with. Have you ever seen Tron? They have that little video game where they are riding bikes, and they're always trying to stay parallel. As soon as they collide, they explode. It's kind of an analogy to electricity, because electricity's got to be separate. I'll spend a lot of time dremeling these just to make sure that everything's separate. As soon as something is connected physically, it's connected electronically. Here's the reflector dish, what it's got to look like. For the one below, there's numbers. You've seen this one before. I kind of invented this one, or at least embellished it. A big fat A right here. You have to move the K to the middle to get the up movements. For Q was one of the tougher ones, full circle, and then this one right here. I want it to be up here, but got to economize. 13 lights, 26 symbols. This is accomplished using diodes. Diodes are a simple little mechanism that let electricity go in one direction. So if A is turning on those 6 lights, 8 lights, and Q also wants to turn on those lights, but wants to use a different combination, you got to use diodes to block the backwards flow, or else every single letter will turn on every single light. This third one is I call it suits. It's our trump flash. It's got a spade, ace, heart, star, diamond stuff, which are I don't know if there's a word for it, but they're kind of modular. If you look at that little picture of suits, you can see clover, you can see heart, and stay. Just a matter of turning on different lights. Here's the one for numbers. You'll see in a minute. I'll show you the animation. Here's what the board looks like, kind of ugly. Put a real little reflector dish on the 7 lights, and you got an object that works. Here's actual physical objects. If you ever worked with lights, there's a couple different kinds. You got the incandescent bulbs and the fluorescent bulbs that go in sockets. That's like 220 voltage or 110 voltage. Kind of dangerous. You don't want to be touching it, playing games with it. If all these were incandescent, I definitely have electroshock therapy going on. As it is, it's just 8 volts, 12 volts, something that you can handle. Worst case scenario, if you feel a jolt, you'll be okay. Worst case scenario for, I've only done it like twice, you know? Like all these experiments, I've only felt the jolt twice. The worst jolt I ever felt was kind of playing with the inside of a TV while I was on, putting magnets towards the back of it. Through space, you can feel the radiation. And crazy guys from Ojai that done too much drugs, you can call me crazy. So you got some bulbs are incandescent that work off of 10, 12 volts. I went to talk apart a basketball scoreboard and found lights like that. And those are cool because energy doesn't matter. It goes through left, goes through right, as long as it goes through, it works. LEDs are one way. LEDs are diodes. And like I said, diodes are one-way things. You gotta put energy one way and it goes out the other. So whenever you wire something together, just stay consistent, and at the end, you just see left, right, doesn't work, right, left works. One of them will. If you have a keyboard at home and you're feeling kind of distracted, kind of creative, you can just open it up. You'll see potentiometers, which are these little guys. A potentiometer is 2 resistors, and they're complementary. Say 128 is the total, or right here 100. So if it's turned all the way to the left, it'll be 0 and 100. Turn kind of middle, 10, 90. Turn even more middle, 70, 30. So that means that the left and the middle will have one side of the output, the right and the middle will have the other side of the output. You can open up a, for like 150 bucks, you can buy a machine that lets you turn your computer into kind of like your own instrument where you have maybe like 10 potentiometers and link in any ones you want. But you can just buy a used keyboard that already has them, open it up, and just solder out the resistor, or solder out the potentiometers and put in wires, and then take those readers anywhere you want. Here's a kind of a ghetto example. Instead of spending 10 bucks on a flex resistor, you just put a potentiometer under your arm, put 2 kind of planks, and then you have kind of 2-dimensional control. It doesn't have 3-dimensional control. I was thinking if like a soft plastic panel was used, then you can kind of maneuver left to right a little bit, and it wouldn't hurt the potentiometer, because they're very linear things. Fader is, you see them on mixers, just a bar wherever the tip is on the bar goes left to right. They can be turned into a tripwire. If you set a taut spring on one side and a wire on the other side, then when the wire is pushed, the fader will open, and then when the wire is left to go limp, then the spring will take it back to 0. So all these sensors and the usage of them has to do with making things that are kind of human, kind of understandable to an individual. And if you hide those behind some cool effects, then people will think that there is a greater power to work. This one's a little picture of a light resistor. Just turn a flashlight on it, and you can turn a motor. That one right there is what a temperature resistor looks like. Put a candle close to it, it'll start going crazy. Motors are another part of this. Again, you got your AC motors, you've seen in fans. You got a DC motor, which are kind of cool. You give them power and negative, and they'll go right. You give them negative and power, they'll go left. You can have a switch that turns it back and forth. Stepper motors are kind of crazy. You need to control them with a microchip. And you give them a control on like 5 different pieces of copper. And you go 1, 2, 3, 4, 5, and then it'll go dip, 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 dip. If you go 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, it'll turn right and then turn left. Harder to control, but once you control it, it's doing a minute, precise step for you. This is a solenoid. You take a nail, you put it through a wound piece of copper, charges the copper, and it's got this clenching power. You'll see it, if you ever open up a drill or a VCR, you'll see that there's this like magnetic circular rotor. They're using an electromagnetic pull to turn